Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. This is going to be an investigation on the transformations of different graphs from the parent function. So what we're going to do is we're going to sketch each of the following graphs based off of what we see from our graphing calculator. First off, what we want to do is go ahead and go to the graphing calculator. As you have the sheet in front of you, what we want to do is put each one of those equations into our y equals. The y equals is in the top left hand corner there. So y1, let's go ahead and put x, so alpha STO, x raised to the second power. You can either do x raised to the second power with the caret button, or you can do x raised to the second power by hitting the x squared. The next equation we want to put in is negative x raised to the second power. The next one's going to be 3x raised to the second power. Then we have parentheses 1 over 3 parenthesis x raised to the second power. Then it will be parentheses x plus 2, all of that raised to the second power. Then we go right back and we'll hit x minus 2 in parentheses raised to the second. X squared plus 2. As you can see, that the x is the only thing getting squared there, and the couple above that, the entire quantity x plus 2 and x minus 2 are getting squared. And the final one is x minus 2. Sorry, it's not correct. It would be x squared minus 2. And what we're going to do is we're going to go ahead and take a look at what each one of those do. As you can see, my window's a little messed up. I can only see one little line. So I'm going to go to, well, when it's done moving here, I'm going to go to Window and take a look. So my x-min, when we're just looking at regular parent functions and whatnot, we want to go ahead and go negative 10 to 10 and negative 10 to 10. Okay, now we can hit graph and take a look at what we have. This is going to graph every single function that I just put in there, so it's going to graph 1, 2, 3, 4, 5, 6, 7, 8 of them. And we'll see what happened here. Now, as you can see, that's kind of a mess. Pretty hard to figure out what's going on. So what I want to do is I want to look at each one individually. So in order to do that, I need to get rid of these highlighted equal signs. I just go down to where it's highlighted and I press enter. That will turn those off, and I'll be able to see just one by itself. Looks like that's all of them. So now I can hit graph, and I should only see the very first one, which is x squared. So as you can see, the vertex of x squared is at 0, 0. That's the endpoint right here. Let's see if I can make this work. Yep. That is where I come to the bottom of my quadratic. So that is x squared. What we want to do is go back to our original paper, and we want to sketch x squared. Remember, it touches right at 0, 0, goes up. Don't forget your arrows. This is known as a quadratic. Now, to see what kind of transformation happens, what I'm going to do is I'm going to go back into my graphing calculator. There will be no description on this one, really, because that's talking about the description of transformation. There is no transformation at this point. Let me go back into my graphing calculator, and I'm going to go ahead and turn on the second equation. So I want to get over to the equal sign, hit enter to turn on the second equation. We still see our first, and the second one comes in. It is a mirror image of the first equation. So now I want to draw it on this paper. Going to make my x and y axis. I want it to touch right at 0, 0, and there we are. So what can we say happened there? Well, what we say happened there is it looks like it flipped over the x-axis, right? So what we call that is a reflection over the x-axis. That is called a reflection. It's kind of like you're looking in a mirror. If you've ever looked in a mirror before, when you lift your left hand, it looks like your reflection's lifting the right, so it's a complete opposite look, right? Let's go ahead and go back now. So I've already looked at my second equation. I'm going to go ahead and take that off. We know what happened there. The negative sign right here tells us that we're going to flip the equation over the x-axis. So let's look at the next equation. I want to keep my x squared in there so I can see what the difference between the two would be. So now I have 3 times x squared. Hit graph. Here comes our x squared. And here comes our 3 times our x squared. As you're looking at this, if you think about holding a string with both hands and having your foot stand on it, when you pull on it, you're stretching it. And the string will come closer together as you pull on it. So the original is just when you're holding it, say down by your waist a little bit, it's kind of wider. When you pull on it, the string will come together because it's getting tighter. Well, that's what's happening when I have the 3 times the x squared. That is kind of making us pull on it or stretch it. So what we say about this, let's go ahead and graph it. We want it to look a little tighter than that first one, so it's going to be just closer to the y-axis as best as we can do there. This is called a stretch by a factor. It'll be stretched by the factor of whatever is multiplying by x, so in this case, it's stretched by a factor of 3. All right, let's go ahead and look at the next transformation. We want to not have that highlighted anymore. Go ahead and get this equal sign highlighted and take a look at what happens here. There's our original or our parent function, and here comes our 1/3 times x squared. So now, multiplying by 1/3 is the same thing as saying dividing by 3. When I divide or multiply by a fraction, what happens is my graph will shrink. We're not going to stretch it anymore. So we're back to the string analogy. If I let my hands drop a little bit, what's going to happen is the string's going to sag, but if you move your hands out a little wider, the string will it'll open up further. We also call that a shrink. So in this transformation, it's going to open up wider, cross at 0, 0, and we call this a shrink by a factor. Well, it's going to shrink by whatever we're multiplying by. In this case, it's the 1/3. Same thing as dividing by 3. So it's a shrink by a factor of 1/3. Okay? Let's move on to our next transformation. So I'm going to go ahead and get rid of the equal sign being highlighted here. Drop it down. Now I have x plus 2 inside of the parentheses, and all of it's being raised to the second power. Well, I wonder what's going to happen there. Well, there it goes. As you can see, it has moved to the left. My first equation starts right here, my first quadratic. After I have the x plus 2 in the parentheses, it actually moves to the left 2 places. Okay? So that is actually going to be what we call, well, you know what? Let's go ahead and sketch that onto our paper. 1, 2. So I'm going to have this drop down to 0, 2, or 2, 0, negative 2, 0, I'm sorry. So we go ahead and moved it over here a little bit. Should be about the same as our original graph, but we call this a translation left 2. So when our number is inside of the parentheses, it's actually going to go opposite whatever the sign is. So that's going to be a left and right movement because it's inside when it's inside the parentheses, and it's actually going to move opposite whatever our sign is. So since our sign was positive, we actually move to the left. If our sign is negative, like in the next one, I bet you can guess what it is, but we're going to go ahead and take a look at it now. And I get those points off there for us. Just press down until I can get back to my equal sign that is highlighted. Get rid of that. And activate this one. There's our original graph. And here comes our new graph. So as you can see here, my original graph started at 0, 0. My new graph has moved 2 places to the right. 2 places to the right. So I'm going to go ahead and graph that now on my paper. Two places to the right. So just like the one before it, it will be a translation. And yes, you do have to write the entire word translation. Right. Well, it's translation right because of the negative sign over here, and it's 2 because that's the number that's inside the parentheses. Well, I wonder what's going to happen now that there are no parentheses, or you could think of this as being outside the parentheses. Because if you look at translation number 5 up here, I do have plus 0 on the outside, and we are going to see some that have 2 movements. So we got to know that there's stuff inside the parenthesis and stuff outside the parenthesis. Well, since there are no parentheses here, I can always make some. There'll be a parenthesis around the x, not around the squared. Okay? So in this situation, let's see what happens. We go ahead and go back down to where we're activated and deactivate that. There it was. And then we will activate the next one. Hit graph. Here comes our original equation. And there goes our next one. Well, it looks like I have moved where? It started here. And it looks to me like we went up 2 places. Well, if we go up 2 places, what we're going to call that is a translation up 2. Well, it's a translation up because if we have something outside the parentheses, we will follow the sign. In this case, it's a positive sign. So positive on your y-axis is up. So that's why it's a translation up, and it's obviously a translation of 2 because of the number 2. Let's go ahead and sketch that on our xy axis. And then the final one, I bet you can guess what's going to happen here. I have a negative sign, and it would technically be outside of the parentheses. So if it's outside the parentheses, we should be following our sign, which the sign in the first one was positive. This sign is now negative. So I want to deactivate one and activate the next one. Let's take a look at what happens. There's our original. There's our new. The original started at 0, 0. My new one has now gone down to negative 2. So it is, probably what you guessed, a translation down 2. So if you remember that everything outside of the parentheses we're going to follow the sign, and those are up and down movements, and everything that's inside the parentheses we're going to go opposite the sign, and they're left to right movements, then you will be perfectly fine because it tells you exactly how far to move everything every single time. Go ahead and sketch that. Now, what it says down here, all of the above transformations will apply to any parent function, including those such as quadratics, which are x squared, cubics are x to the third, and these are square roots. So it'll work exactly the same way for all of those. Let's go on to the next page and see what's going to happen with x to the third. So I want to go back here. What I'm going to do is I am going to jump ahead and have all these cleared out for you. And when I get back, all of the next equations for the x to the thirds will already be put into the calculator for us. And you can just watch what's going to happen. So I'm going to go ahead and stop this now, clear all these out, and come back in a minute. Alright, as you can see here, I have already put in all but the original graph. I wanted to show you guys how to raise something to the third power. So what I'm going to do is hit alpha STO to get to my x. As you can see, the red buttons are the last things I've hit. In order to raise it to the third power, I'm going to hit the caret key, which is right there, and then 3. So it's just x raised to the third power. If you need to slow down the video to see that, go ahead and do so. I'm going to hit graph to take a look at what would happen. So here, this is what's known as a cubic graph. It's going to have two different legs, one in the lower part of our graph and one in the upper part of our graph. They will always be opposite of each other like that. Those are always going to be opposite of each other. Okay? So let's go ahead and go back here. Well, we need to actually sketch that real quick. So the original graph for x to the third is going to be like this through 0, 0. Okay? This is known as a cubic. It is very important that you remember all those names. Quadratic is squared and cubic is cubed, or it's raised to the third power. No description of transformation because that is also our parent function. If we go back to our calculator, let's go ahead and activate, let's go ahead and activate our 4 times x to the third. If you remember from the front page, this should stretch our graph, so it'll make it tighter to the y-axis, and as you see there, it does in fact do so. So if I go back here, I want to sketch that. I want to see that it's closer to the y-axis all the way through, because I have stretched it. Well, how would I write that? As a description, it would be stretch by a factor of 4, because I'm multiplying by 4. Think about multiplying. This is another way to think about it. If I multiply, I make it larger, or I stretch it out some. Okay? Let's go ahead and go back to our calculator, look at our next equation. So I'm going to deactivate this one and reactivate the 1/4 times x raised to the third power. This should, if you remember from the other side, shrink our graph or make it open wider. And again, as you can see, it does in fact do so. So we're going to go ahead and sketch that. It should be wider than the original graph. Something along those lines. And what did we call it when we multiplied by a fraction on the front? Well, we called it a shrink. So we're going to shrink by a factor of 1/4. Okay. Number 3, our last one with the cube roots, or the cubes here. We want to go ahead and deactivate our second equation and reactivate our third equation. Take a look at that. Here comes our original. Well, it was inside the parentheses, and we talked about on the front that inside the parentheses, I'm going to move left and right. If you remember from this first page or the front side, if it's inside the parentheses, it's left and right, and I will not follow my sign. So if we go back here and take a look, this is x plus 5 that's inside the parentheses. So since it's plus there, I will move in the opposite direction. On my x-axis, that is in fact left. So I'll move left 1, 2, 3, 4, and 5 places, and go ahead and graph that. So this is a translation left 5. Okay? Same thing goes for our square roots, except in a square root, if it's under the square root, that counts as inside the parentheses. If it's outside the square root, that counts as outside of the parentheses. So this one would be considered inside the parentheses. This one here would be considered outside the parentheses, and this one would be considered outside the parentheses. So go ahead and give me an idea of what you think the translation description would be. Take a second, go ahead and pause the video and write those down. When you come back, let's see how you did. Then we'll take a look at what each one of these graphs looks like. So go ahead and pause the video now. Well, the original is not going to have a description, so I do not have to worry about that. The first one is going to reflect over the x-axis. It does that because of this negative sign. The second one, that is inside of the parentheses from what we talked about before. If it's inside the parentheses, then I'm going to go opposite the sign. The sign here is negative, so left to right movements, my positive direction would be to the right. So this is a translation right 5. The third one, that is outside the parentheses, and if you remember from what we've talked about before, if it's outside the parentheses, we're going to follow the sign. The sign here is positive, so is a translation up 4. And the final equation, again, it's out what we'd call outside the parentheses, in this case outside the square root. If it's outside, we will follow the sign, so it would be a translation down 4. Okay? Let's take a look at what I'm going to do right now. Is I'm going to go ahead and clear out my y equals and just look at the parent function. We already know what it's going to do to flip it, or to translate it in each situation, so I do not necessarily need to show you all of those. What I will do is go ahead and hit second, and x squared will get me the square root sign. Hit alpha, STO, that will give me the x. There is my square root of x. If I graph that, this is what we're going to get. It goes only above the equation, because I cannot have negative numbers inside of my square root. Those are actually considered imaginary numbers. So for the first one, what I'm going to do is go ahead and graph that. Looks like this. Okay, so for number 1, can we get a sketch without using the calculator? Well, sure we can. Make our x and y axis. It reflects over the x-axis, so it's going to be based off of this one. It's going to reflect or flip over the x-axis, so it's going to look like that. What about number 2? Well, number 2 is also based off of my original, and it's going to translate right 5. Well, my original started at 0, 0, so I'm going to move 1, 2, 3, 4, 5 to the right. Start at 5, 0, and move up and out. Number 3, I have a translation up 4. So again, that's based off of the original or the parent function. I would go up 4, 2, 3, 4, and go from there. And finally, my last equation is a translation down 4. So this is 1, 2, 3, 4. It's going to start there and also go up and over. Now, if I had a negative out front of any of those, then they would flip over the x-axis or reflect over the x-axis, which is the first movement that you would come to reading it left to right. So that's the first thing you would do. All right, so that is the end of our lesson. If you remember the fact that our translations work like this. Anything inside the parentheses or underneath the square root sign will move our graph left and right, and we will go opposite the sign. You will be fine with those. Any number that's outside the parentheses will move our graph up and down. And we will follow the sign if it's outside the parentheses. You'll be okay with those. And the negative out front will in fact reflect our graph over the x-axis. And if we multiply out front, that will stretch or shrink depending on if we're multiplying by a whole number or a fraction. If you remember those things and the names of each graph, you will be more than fine moving forward. Thank you for watching this video and have a great day.